This is an old newspaper. It has become dull and looks different from today's newspaper. But how did the color of the newspaper change? Let's find out. Paper is made from wood, which contains lignin. When lignin is exposed to air for a long period of time, it undergoes oxidation and the paper turns yellow. Do you know what oxidation actually is? Oxidation can be defined in terms of oxygen, in terms of hydrogen, and in terms of electrons. Let's explore them one by one. In terms of oxygen, oxidation reactions are the reactions in which the addition of oxygen to a substance takes place. Here, oxygen is added to magnesium. In terms of hydrogen, oxidation reactions are the reactions in which the removal of hydrogen takes place. In this reaction, hydrogen is removed from hydrogen sulfide. All compounds do not have oxygen and hydrogen, but they all contain electrons. Therefore, an oxidation reaction can also be defined as a reaction which involves the loss of electrons. Here, sodium atom is losing an electron to form a sodium ion. Similarly, a ferrous ion loses one electron to form a ferric ion. Now, we know that reactions involving the addition of oxygen are known as oxidation reactions. Do we also have a specific name for reactions involving the removal of oxygen? Yes, these reactions are known as reduction reactions. Reduction reactions can also be defined in terms of oxygen, in terms of hydrogen, and in terms of electrons. In terms of oxygen, reduction reactions are the reactions that involve the removal of oxygen. Here, oxygen is removed from copper oxide. In terms of hydrogen, reactions that involve the addition of hydrogen are known as reduction reactions. In this reaction, hydrogen is added to chlorine. In terms of electrons, reduction reactions are defined as the reactions involving the gain of electrons. In the given example, a chlorine atom gains an electron to form a chloride ion. A ferric ion gains an electron to form a ferrous ion. Now, we will carry out an oxidation reaction in the laboratory. For this, we will take 1 gram of copper powder in a china dish and heat it. After some time, you will notice that the copper powder is coated with black copper 2 oxide. It happens because oxygen reacts and is added to copper and copper 2 oxide is formed. It means an oxidation reaction has taken place. Let us now pass hydrogen gas over the heated copper 2 oxide. Notice now that the copper 2 oxide is converted to copper. During this reaction, copper 2 oxide loses oxygen and hydrogen gains oxygen. It means that here, both reduction of copper 2 oxide to copper and the oxidation of hydrogen to water have taken place. Thus, we can conclude that sometimes both oxidation and reduction reactions take place simultaneously. Such types of reactions are known as redox reactions. Let's consider some more examples of redox reactions. When zinc oxide reacts with carbon, zinc metal and carbon monoxide are formed. Notice that in this reaction, carbon is oxidized to carbon monoxide and zinc oxide is reduced to zinc. Similarly, manganese dioxide reacts with hydrochloric acid to form manganese chloride, water, and chlorine. In this reaction, hydrochloric acid is oxidized to chlorine gas, whereas manganese dioxide is reduced to manganese chloride. Since a redox reaction involves both oxidation and reduction, in a redox reaction both loss and gain of electrons take place. Here are some examples of the same. Remember that during redox reactions, the number of electrons lost is equal to the number of electrons gained. Oxidation reactions play an important role in our daily life. Corrosion of iron and rancidity of food are common examples of oxidation. Corrosion is the process by which metals are eaten up gradually by the action of air, moisture, or other chemicals on their surface. Rusting of iron is an example of corrosion. The black coating on silver articles and the green coating on copper articles are other examples of corrosion. Corrosion damages the bodies of cars, bridges, iron railings, ships, and all other objects made of iron. Since corrosion is a destructive process, therefore, it is essential to prevent metal objects from corrosion. It can be done by painting metal surfaces, by greasing, or by galvanization. Let us now talk about the other common oxidation reaction known as rancidity. Rancidity is the deterioration of fatty and oily food by oxidation, leading to unpleasant smell and taste. The presence of traces of metals like zinc, iron, etc., and other factors like light, water, bacteria, and molds speed up the process of rancidity. Rancidity affects the quality of the food, and so it is essential to retard this process. It can be done by using airtight and light protective packaging, antioxidants like vitamins A and C, spices such as clove, cinnamon, rosemary, and sage, nitrogen gas in bags of chips or other foods. Now, let's summarize the concepts we have learned.